MTDCNC are at FRAZER NASH Manufacturing today, and with Andy Brooker. This is a little bit of an educational video about 3D, additive manufacturing. Andy, firstly, tell us very briefly about the additive manufacturing side of FRAZER NASH.
So it sort of makes up a small proportion of what we do, about 5% or so, but it's steadily growing. We use a laser-based technology, which is powder bed, so you can produce much more intricate parts than you can do with like the other side of the metals. We've stuck with Renishaw, and to be fair, they've been absolutely fantastic since day one on that kind of thing. So,
and you are into development management of this side of the business, so you're looking out for new customers and new opportunities. Are you finding many?
Yeah, I mean, to be fair, we've spoken to many people. In fact, it's kind of nice niches within AM is that people come after you. So from a sales perspective, it makes my life an absolute dream. It's very obviously in the public eye at the moment. Everyone's trying to explore it to different levels. We do have flying parts these days, which is you never thought of 5 years ago.
It's a bit of a buzzword. Now, what's really intriguing here is we're going to look at a component which, before you did it in this way, was much bigger, wasn't it? Can you just explain the differences between how it was made before and what we've got here now?
Yeah, so this is a manifold for an actuator on an aircraft wing. The original manifold was about 250 mil square, so I mean, you can imagine the intricacy of that. We worked with a company, this is actually for Dominion Power, and to be fair, it's a fantastically designed manifold system. There's about a metre or a metre and a half of internal chambers within this part, right from the beginning as well. So it works just as well. I mean, to be fair, if anything, it's actually improved the functionality with the swept curves. So fluid dynamics is far more improved than what you would to traditional machined components. So
not only is the part smaller, or the actual component or the structure smaller, but it's also more efficient as well, would you say?
Yeah, so there's improved efficiency. Obviously, lightweight in aircraft is worth an absolute killing at the moment. So,
what about the strength?
The strength is very, very similar to that of wrought material, so there's no sort of drawbacks within it now. It's all about, with AM, it's all about engineering to the materials that are available. There's still limitations on the materials, but every week there's new ones that are being mentioned. So, what
about the cost of making that compared to how they did it before?
So cost is very similar. Again, it all comes down to design work. Not every part can be printed, and not every part you want to print. It's all about picking the right components and redesigning them, really. You have to start from the ground up rather than adapting them.
Is there a printing time for that part?
So this part, I think we did a bed of about 9 or 10, and it was around about 15 hours, which although sounds like a long time, these machines run lights out. So we start it on a Monday, it's finished on a Tuesday, and they're 75% complete.
Wow. So that's 15 hours for that?
It's about there, yeah.
Okay, cracking. Now tell us about this second part here.
So the second part is a cut through of the actual manifold in my other hand. So it just shows the intricacy of the chambers. As I say, it's not just what you see on the top, it's all about what goes inside. And this is a real key feature of what AM is all about. The internal features, you can't make them any other way. It's sort of every designer's dream for it.
You talk about selling earlier and sales pitching. You've got the perfect role now because there should be lots of opportunities out there. Hopefully, this will hope to elevate FRAZER NASH manufacturing from an additive manufacturing perspective, because you can see here they've got a lot of skill and there could be an opportunity for people to re-engineer and save money. Thank you very much for your time, Andy.
No problem.